our another most advanced SAT Math Level 2 question, especially about our rational function, is going to be which of the following is the equation for our asymptote of a rational function of our f of x, which is 3x squared minus 2x minus 1 divided by 9x squared minus 1. So before we solve for this question, what should we do? We need to think about what are the problem analyzed. We need to think about analyzing this question before we actually get to or approach this question. So let's think about things we need to know in order to solve for these questions. What can we know through the questions in order to analyze our problem? Well, we know that according to its problem, it says it is an asymptote. What is the asymptote? Well, we know that the asymptote is one of the main elements that we use for our limits. And so this question is basically about our limits. And what is the thing that we can apply to our limits? Well, it will going to be a rational function. So this question, it will basically lead to approaching our rational function because of our limits, and the limit was originated from our term in our problem, asymptote. So what we need to do here is we need to think about the problem analyzed before we approach our question. Well, we know that asymptote is related to our limits. So what is the first thing we need to do in order to solve for this question? We need to think about what is our limits. So the first thing is what is the definition of our limits? The definition of our limits. And what is the limits? It is a most important thing when it comes to solving our asymptote problem according to our question. So the definition of our limits, which is the most important thing in a rational function too, that defines a rational function, is going to be the limit, which is the most important thing in our, which is the most essential thing in our rational function. Definition is going to be the limit is always going to be a value. That means there will be a specific value that is given, that only a function or a sequence approaches. So they are approaching something, and what they are approaching as the input value. What is the input? Well, if you convert into an xy coordinate, it will be an x value approaches. And what does our input value approaches? Well, our x value approaches our undefined values. Undefined values. So this is what it means by the definition of our limits. It is a value that a function. What is a function in another way? Well, we can notate our function as the f of x, and a sequence, which is a set of our numbers, approaches. So our function or a sequence approaches as our input value. The reason why this is wrote input as our x value is because input is a thing that generates this sequence and a function either. And the x value approaches our undefined values. What is the undefined values? They are the values when you make it the answer or the values of each undefined values turns to 0. This is what the undefined value is going to be. And as the x value approaches the undefined values, this is what the limits of our rational function is going to be. This is what the limits in our rational function's definition is going to be. So as we thought about the limits, we are going to approach the first thing that we need to know in order to solve for this question, which is the definition and the types of our limits in our rational function. But we need to remember that the most important thing in our question in this case is going to be a asymptote, because without that term we won't be able to define that this question is about the limits or a rational function. So right now, what we are going to do right now is think about. So what we're going to do is think about the types of our limits, including its own formulas. So there are totally two cases in our types of our limits in our rational function. But the types of our limits, which means its own formula, are all exactly similar, except The first case will be when the first formula will be when the limit of our x value is approaching our some specific value. We'll just call it as c of f of x. What does this value is going to be? It will show a function, and we'll explain why this value shows a function. And what is the second type? Well, our second type's formula is going to be the limit. When the limit of our, let's say, our a value is approaching our b value of f of n value, what is this value is going to be? This value is going to be a sequence. What is the different meaning of our sequence? Well, the sequence means it is a set of our specific numbers in our own pattern, or its equation that it contains in it. And using all of these terms, if you add all of them, this will turn into what we call our limits. This is what we call our limits. And we need to think about what is our most important thing in our limits. Well, it will going to be a rational function, as we have talked about this in a lot of videos. And right now, we need to talk about why this value is the function, is about the function, and why the second one is about the sequence. Well, we could have figured out these values through a given definition. What did the definition of the limit says? Well, it is a value that the function or the sequence can approach. So there should be two values, the function or a sequence. That's why there are totally two values, the function and the sequence. And their formula are exactly the same except for the values. Except for the values of our input values, where our limit of our function should always be x value, and our sequence should be any kind of number or variables except for our x value. So these two things are the general terms that generates our limits. And remember that limits is the most important thing in our rational function. This was our types of our limits. And what is our equation is? Our equation is to solve for the f of x is equal to 3x squared minus 2x minus 1 divided by 9x squared minus 1. So if you write it down again, the f of our x value, our original one that we're trying to solve, which is 3x squared minus 2x minus 1 divided by 9x squared minus 1. Well, we always can see that it is the f of x. What is the x value? What is the f of x that contains its own input as our x value? Well, this question is going to be about the function problem. So this question is going to be something about the function problem. So this question is basically going to be about a function problem, but exactly what function is about the rational function. The only reason is because we can only apply our limits to our rational function. And this was compared to the definition of our rational functions in lots of videos. Now, we're thinking about the function system, which is the limit, when the limit of our x value approaches our c value of f of x is equal to some specific value. We'll just call it as b, which is our function systems. But right now, what we're going to do is, there are also two types in our function limit systems of our limit systems. So what we're going to do is we need to think about the types of our limits of specific function values. So as we have talked about this, there are totally two values in our function problem. And we need to think, I'm going to talk about how can we solve that limit problem depends on times. Depends on that two types, two cases. Before we do this, these types of our function will be defined by the values. These functions, limits will be defined by the values that our x value. And what is the x value? Our x value is our input of our function approaches. It will be defined by the values that the x value approaches, and the main approachment will be defined the value we'll write it as the n value. And obviously we know that n value is a short form to represent the number, and it is a variable. And what is a variable? Variable is a term to show that they are the numbers that are not defined yet. They can change depends on times. And that values will be by inequality. And the inequality will be if it is less or equal to our infinite value. So there will be two cases where it is less than infinite value and is equal to infinite value. So let's think about two cases. The first case is when our x value, which is our input of our rational function, is approaching the n value, which we're just gonna notate it as our number that should be a variable that changes or varies depends on times. When the n value approaches that is less than infinite value, then what will the formula for it is going to be? Well, the formula will be when the limit value of our x value that is approaching the number that is less than infinite number. This is how to show the x values approachment, and then we will have our own function which we'll notate as our f of x. And how do we solve this question whenever the x is approaching the number that is always less than our infinite value? Well, this kind of question will obviously, or 100%, going to be reducing. This kind of problem where the n value of the x approachment is less than infinite value should always 100% be the reducing values. Reducing, or we can say simplifying our fractions into the simplest form. And what is the simplest form? Well, the simplest form is a form between our numerator and denominator that can never be divisible at its simplest form. And if you remind yourself what this is about again, and when the x value, which is our input, is approaching the number that is always should be less than 100, less than infinite value, this question should always 100% be the simplification question, where we need to factor our numerator and denominator, factor our numerator and the denominator, and then factor them out in order to solve for our infinite values. And this is a first case as well as the first way to approach the question. And this question will always gonna happen when our x value, our input value, is approaching the number that is always less than infinite value. Then obviously the second case is going to be the case when our limit value of our x value, which is our input, is approaching the number that is always should be equal to infinite value, and it will always contain its own function, which we're just gonna notate as our f of x. And how do we solve this question? When the value of our x value, which is the input, is approaching the number that should always be equal to infinite value, well, this question should always 100% be the question about our asymptote. This question should always 100% be the question about solving the asymptote, unlike the first one where we had to simplify our fractions. This question will 100% be the asymptote. And right now, we need to think about which function systems we're defining. And what was our asymptote of our rational function, by the way? This is always should be related to our rational function. And now what is the first thing we need to do? Well, when you think about which function that we are trying to deal with, well, they gave us the functions. It is equal to f of x, according to his question. F of x is equal to 3x squared minus 2x minus 1 divided by 9x squared and minus 1. This is a function that we're trying to deal with, minus 1. So if you read it again, what it is, the f of x is equal to 3x squared minus 2x minus 1 divided by 9x squared minus 1. This is the rational function that we're trying to deal with. This is a rational function that we are trying to deal with. And what is, we don't know yet. And we don't know that we are trying to solve for the limit when the n value is going to, that is to the n value that is less than infinite or exactly equal to infinite. So let's go back to our original question to see that which kind of function systems of our limits we're trying to approach. And as we can see, the question said we're trying to solve for the asymptote. So we're trying to solve for the asymptote of our rational function. And what is our asymptote's formula? That it will be limit x value when its x value is approaching the n value that is exactly equal to infinite value of f of x. This is what the situation where we need to apply our asymptote to our function is going to look like. So this question is always going to be something about our asymptote problem. And before we think about what to do with, we need to think about what is the definition of our asymptotes. So if we do it in a white color, where we can see that this is the third thing that we're trying to solve, what is the definition? What is the definition of our asymptotes, which is the problem that we're trying to deal with right now? And the main point in this case will be depends on the word or the term asymptote. And the definition of our asymptote in our rational function is going to be is a line, it can be either a line or a curve that continually, which means it keeps going on to do something and it keeps going on to approach, goes closer to a given curve. But the most important thing about the asymptote is that it never intersects with that given curve or line at any finite distance. And when is a time that we use or apply our asymptote? It is a time when our limit value of our x value, which is the input, is approaching our n value. That is always should be equal to our infinite value and the f of x. This is a time when we apply our asymptote in our function systems. And so after we thought about the definition of our asymptote, the next thing that we need to do is think about the formulas to solve for the asymptote. It will be the third one. It will be the formula of the asymptote, and they will always going to be defined or originated from our standard form. And standard form of what function? It will be a rational function, because the rational function is the only function we can apply in our limits problem, or including the asymptote. So the third thing will be what is the formula of our asymptote in our rational function. Well, the formula of asymptote, we always need to think about the standard form of our rational function. What was the standard form, which is the most basic format of our rational function? It was f of x is equal to ax squared plus b, all of them divided by cx squared plus d. And obviously we know that this is a part of our fraction. And the reason why the function of our f of x is a fraction is because according to the definition of our rational function, the rational function can be any single function that is formed by a fraction, especially the numerator, and the denominator should be formed by a polynomials, which is anything that has more than 0 nomials. So this is our standard form. So this is what we call a standard form. Standard form of our rational function. And the formula for our asymptote is really easy comparing to all of the things that we have to do in order to think about it. The formula for our asymptote is going to be A divided by C. What is the A value? Well, the A value was the coefficient. The A value was the coefficient of the first x squared term in the first nominal. And what was the C value? Well, the C value was also a coefficient, but a coefficient of our x squared term in the second nominal. And using these two terms, we'll be able to define what the formula of our asymptote in our rational function will look like. And after we thought about the definition as well as the formula of our asymptote, and we can actually apply this to our original question. And what was the function that we're trying to deal with? Well, it is f of x is equal to 3x squared minus 2x minus 1, all of them divided by 9x squared minus 1. Even though the limit, when it comes to converting our function into this one into a limit, won't be a matter when it comes to solving this question, but let's actually convert this into a limit, because the limit was the whole point of learning this question. And when is the time when this question is always going to be about solving the asymptote? And as we have thought about it, what is the limit? The limit, when is the x value approaching? When the x value is approaching exactly a finite value. And when it actually a finite value, because it is the definition of our asymptote, there should be a function f of x should exist. And what was the f of x? Well, the f of x was our original function, which is 3x squared minus 2x minus 1 divided by 9x squared minus 1. So f of x was 9x squared minus 2x minus 1, all of them divided by 9x squared minus 1. So this was a conversion between the original function to our limitation, the limit of our rational function. And then what should we do next? All you have to do is solve for the asymptote. What is the asymptote of our rational function as well as the limit when the x value is approaching our finite value? 3x squared minus 2x minus 1, all of them divided by 9x squared minus 1. Well, we know that the formula for our asymptote was a divided by c. What was the a value? A value was our coefficient of our first terms at a polynomial, x squared term. What was the c term? C term was also a coefficient of the x squared term in the second nominal. So if you find its values, what is the a value? Well, a value is the first term's x squared's coefficient, which is 3. And what is our c value? Well, our c value is a coefficient of our second degree term's x value in our second nominal, which is 9. So what is a divided by 9? A divided by c. Well, we know that a is our 3 and our c is 9. A divided by c, which is a formula for our asymptote, is same thing with 3 over 9, which is also a same thing with 1 divided by 3. 1 divided by 3, so our answer for this question, which is the asymptote of our rational function f of x, is equal to 3x squared minus 2x minus 1, all of them divided by 9x squared minus 1, is going to be 1 divided by 3.